Hello and welcome to another Whiskey Hour. We're going to talk about some legacy code, or in this case, that moment of transition between a wonderful new prototype and a product, wherein we have a ton of legacy code. So I ran into this situation a couple weeks ago, which I'm sure none of you have ever run into before. We'd just done V05 of the product. Right? We'd done many pivots. We'd finally found exactly what the customer wanted. We had a happy, delighted customer. We could tell that because the customer switched from saying, I don't know, maybe this, to, oh, yes, and now I want this and this and this and this and this and that. Right? So we're in that situation where the code base is just pivoted everywhere, which means it's not the greatest design for anything, because it's a little bit of everything. Right? At the same time, our customer demand has just increased tenfold in terms of the new features to develop. Right? I'm sure none of you have run into that before. Right? So in this case, the product was a little estimation tool, but not for software projects. It's a tool for estimating real things. Right? So it consists of a UI, people add their options and choices, and then a bunch of logic and expert knowledge on the back end that results in outputting a number. Fantastic. So let's look at the problems that we had there and the solutions that we came up with, because this is a common situation, and what we wanted to do was go forward, continue adding features, but at the same time make those refactorings that were necessary to allow us to add features quickly and safely without slowing down our feature development. So the first thing that we did was we had identified, as is commonly the case, there's some core piece of functionality that's used throughout the project, and it's often supplied by a library. Right. We had that situation. We had a library that was doing measuring, and we had extended that measuring unit-based library to be able to do trackable measurements, so that when a math operation happened, you could see where the data came from. It was cool and wonderful and what we needed. And like usual, the use of that thing is spread throughout the code base. Right? It's a core functionality. That means it's used everywhere. Right? So the refactoring that we did here was we wanted to isolate this library. We're going to grow an adapter. Right? But we don't want to just go all at once and try and build a whole adapter or completely separate the library or anything. Those are hard, right? And they'll get in the way of doing development. So what we did was we first just moved the files that defined our extensions and modifications of this library into its own subdirectory and updated all the usages, right? That was fast. It took, 5-10 minutes, right? And then the next thing that we did was we turned that subdirectory into a library, sort of. We altered the way that we did the export and import so that it was effectively its own library and it managed its own dependencies. Even though it was still part of the same build, still part of the same source tree, everything's exactly the same, except that it's imported and exported within the language. Now, we were using JavaScript, but you can do the similar in other languages. It's imported and exported within the language as if it were its own separate library. Right. Then we went ahead and did what we would normally do for an adapter there, and we extracted a little bit of an API and made a little port and simplified down our usage and so on. We never ever pulled it out to be its own separately built library. That's the point. Like, we were able to do enough of a change to isolate this and to, most importantly, isolate all of its dependencies, those external libraries and all that stuff, so that our regular product code didn't depend on that. It only depended on our new simplified API, right? And by using the library boundary, we could ensure that that was the case, right? It wouldn't compile if we accidentally did something that depends on their library directly, right? So we got all of the benefits without the costs of actually separating the build system and doing all of that sort of thing. And that's the key to a lot of these things. How can we do a change that gives us the benefit so we can continue doing story development without paying all of the costs to do it, quote, right? Right. And then later we will do it right as we build out more and more of the system. Right. So the next problem that we had, of course, is merged concerns, conflated concerns. We had, in this case, the code that's allowing the user to choose the options that are going into how should I calculate this estimate, and the code that's actually doing the calculation on the basis of those option settings was moderately tightly coupled. Right. Because we built it out for the one piece, and it's like, well, here's the information I need from the user, and then here's the calculation I'm going to do. Right? We wanted to separate those two concerns because it turns out, we discovered in our later pivots, that the user doesn't actually select them in the same way that we present them in the output. We thought originally that they would. That turned out not to be the case. So now we had these two things that don't quite line up all intertangled. So we needed to separate them. Right? So what we did was we introduced intermediate data. right? And this intermediate data object has two pieces to it, right? It's got all the scratch space that's going to be used for calculating the estimate, and it's got all the space that's going to be filled in from the user interaction. Now it's separate from the data stores. Like there's actual data stores as part of a view model that's used with the UI toolkit. That's all done, in the UI layer. But then when we want to do an estimate, we copy that to a specific place in our intermediate data, right? And then we can have our regular estimation tool use it from within that. It can reference whatever it needs. Now, the important parts on here, one is that we never modify any data in place. We don't operate on and change data, we copy and move it, right? And another one is that we are going to extract from the UI one time into one isolated place in our new data model. And that allows us to create this pipeline of phases, where first we're going to get all the data off the UI, then we're going to start performing calculations to extend that and to get to our estimate, right? So we're defining that data pipeline and its big segments. Right. This is very common. We see a ton of applications out there that do a bunch of data transformation, data processing. When you get that, pipeline makes a lot of sense. And you want to make sure that you've got a data model that goes through so that each couple of phases of the thing can operate on the same data model. Right? So we have one shared data that's used as the destination for copying data off the UI, and the source for performing those calculations, and the destination of those calculations, right? And that allows calculations to depend on our prior calculations and whatever we might want to do, right? And yet we never modify data in place, right? So that is a really cool system for just separating those concerns. We then could break out the pieces that are going to copy things from the UI. We could break out the UI itself, and we could break out the estimation. Wonderful. So now we've separated concerns, but then we run into another problem, which is we've got concerns that are too separated, right? So we're doing all of these shotgun additions, right? When we wanted to make a new node of the estimate, we wanted to calculate a new kind of thing, we couldn't just add a new component that's adding this estimate. We had to go in and add a piece here, a piece there, a piece in this other place, because there were a whole bunch of things that were doing estimation calculations, and it was, again, because of the pivots, not broken up in the way that turns out to be the right answer, right? So what we're doing here is we're gathering a component, right? So we go and look at just the existing code, and we gather together all the pieces that are related to one estimate, and then all the pieces that are related to another portion of the estimate, and so on. And we just gather these components into what turns out to be our discovered domain, right? So that's the key here. We didn't know what the domain was. We discovered the domain by interacting with the customer, which means the code is not aligned to the domain. So now the code does the right thing, but it doesn't think the right way. It doesn't cluster things the right way. And so we're composing each of those out into components that match the domain. Like, oh, okay, this is one piece of the estimate. Let's calculate that. This is another, this is another. Oh, now these are shared data that are used by these, so we're going to pull that out to its own thing. We're going to add dependencies and so on. So once we've got all these components, we now have this graph of nodes, each of which performs a portion of the calculation and has some dependencies. Right? So I want to make sure that I can extend that graph and add new things and not break stuff. And that means that I need to make sure that I register them all so that I can just execute everything. I don't have to keep updating some function with, oh, and now add this and now add that, because I'll forget to do that. Right? So I need just a set of them that I can make sure is the right set, and that it'll be guaranteed to execute. I need to make sure that set's in the right order so dependencies are resolved. Right? So what I did is I wrote a couple of tests for that, for the components that we created. Right? And then since I'd done 2 or 3 components that we'd created, I then started looking for commonalities in those tests, and I started extracting a library. And what I'm really doing here is I'm extracting a higher order test. Right? And so I'm going to pull out all the common things. That made it so that then when I tested one of these estimate components, right, I said, run the estimate component tests, and here's the extensions that you want to do. Here's the way that you look at output data or the input data that you're doing or whatever it is, right? That made it so that when I'm writing my next new component, I'm going to call the same estimate test thing. I'm going to use the same library, and it's already filled in a number of the tests that I'm going to do, and it's telling me which input data and output data to check and verifiers to add, right? So that both makes it very fast for me to create new tests, and it also means I can't forget something. I can't forget to write the registration test, because by saying this is an estimate, tested accordingly, it runs the registration test. right? So once I've created these reusable tests, now I can easily add new components, because each component I go and add, and it immediately starts giving me 5, 6 test failures, and that tells me go and do your registration, supply your dependencies. Okay, now you've got that, go ahead and implement your logic. Okay. So these were 3 refactorings that I see over and over and over. So the first one, again, is I've got a library, I've got some piece of functionality that's used throughout my whole system. I have discovered over the course of all of these pivots and interactions that this is really the heart of the system. I want to isolate that into its own library, its own component, and use that through a clean boundary. Right? So isolate the engine. Right? And for that, I want to do enough to isolate the engine, but not so much that I have to make a whole build system and all the complaints right there. The next thing is I will have concerns that are overly merged. Right? Merged and conflated concerns. So in that case, I want to pull them apart, and I find a data flow pipeline is one of the most common patterns to do that. Right? Just like in the first one, it's ports and adapters. In the second one, it's this data processing pipeline. Right? And so I split out the segments of the large-scale steps, and I have shared data so that I can have implementations of each step modify on that data as things flows through the pipeline. Right? And the third one is separated concerns, where things that should be together are split apart. Commonly, you'll see this like in a data flow pipeline, where I've got the thing that goes into the first part of the pipeline and the second and the third, but are all for the same domain object, and they're scattered together, right? And so I need to gather those, right? And so those are where I'm just gathering a component, and the key element there is to not just gather the component, but once you do that, gather the tests and create a uniform testing library that everything can share. Now, all of these, in this case, allowed me to, over the course of about 10 hours of work, dramatically reduce the going forward time for everything that I needed to add, and significantly reduce the number of errors. So it took me about 2 or 3 days before I hit the break-even point. And that's what I commonly see. In this case, I had done something around the order of 20, 25 days in order to find the right product and doing all the pivots. And something like 10% of that, 2 to 3 days, was enough to get the whole thing into a situation that I'm ready to go forward. And during those 2 to 3 days, I, of course, implemented at least one, in this case 2, new features, which allowed me to see that I was doing these refactorings the same way. So hopefully you find that useful as you are taking your product from the early prototype, the thing that found market fit, to the product that you can extend, embrace, and go forward with. Thank you for joining us in this conversation about legacy code. And if you found this useful, or, I guess if you didn't, join us at the next Ask Me Anything, where we're going to have a quick lightning talk, followed by general questions, either related to the topic of lightning or not. Whatever it is that you find most interesting or most perplexing when you're working with legacy code. I hope to see you there. Cheers.